Hello students, I am a Dr. S.M. Bhati. The objective of this video is to evaluate inverse Fourier transforms of some functions. Let's take now one example where we have to find Fourier sine transform of the function. You can see that this function fx has three values. First value is x, second value is 2 minus x, and third value is 0. The function has value x when x is between 0 and 1. The function has a value 2 minus x if x is present in the interval 1 less than x less than or equal to 2, and it has a value 0 when x is greater than 2. Fine. Now Fourier sine transform of the function f of x is capital Fs lambda, and it is given by the equation 3a. So you can see here equation 3a. In 3a equation there is a du, that means u is a variable of integration and lambda is constant here, and here we need to put the value of f of u. But we don't know f of u, we know f of x. So from f of x, this f of x is known, right? From this f of x, we can write down f of u. Simply you put x is a u everywhere, so that f of u will be a function having the value u when u is between 0 and 1. Second value is 2 minus u when u is between 1 and 2. And third value is 0 when u is between 2 and infinity. Now from the equation 3a, if you look at this interval, and in the equation 3a we have integration with respect to u, and u has a limit 0 to infinity, and here we have to put the value of f of u which is valid in the interval 0 to infinity. As fu has three values in these three respective intervals, so if you want to put the right value of f of u, we must split this integration by considering these intervals. That means interval here, integration 0 to infinity should be split in three integral. First integral will have a limit 0 to 1. Second integral will have a limit 1 to 2. And third integral will have a limit 2 to infinity. So using now 3a and the definition of f of u, we can split this right hand side of this equation as a three terms. First term integral 0 to 1, second term integral 1 to 2, third term integral 2 to infinity. And this integrand, that is f of u sine lambda u du, remains same for all three integrals, right? And now in first term you have to put the value of f of u. Now when u is between 0 and 1, f of u is u. So in first term we put f of u is u. While in second term we have u from 1 to 2. So we have to put the value of f of u which is valid in the interval 1 to 2. And when u is between 1 to 2, the value is 2 minus u. So we have to put here f of u as a 2 minus u in the second integral. Now in third integral, u is from 2 to infinity. So when u is from 2 to infinity, the value of f of u is 0. So in third term, we put the f of u as 0. This you have to understand. Fine. Now after that, you have to make a simplification. Now we can observe that the last term became 0 here. And in first term, because there is a product of u and cos, u and sine, and u and sine. So we have to apply generalized rule of integration by parts in the first integral, and in second term also there is a product of 2 minus u and sine lambda u. So again we have to apply the generalized rule of integration by parts. So by generalized rule of integration by parts, we can get this next step, and when you simplify and when you put the respective limit, that means first we have to put u is 1. When you put u is 1, you will find this, and when you put u is 0, you can see that the first this term became 0, Also second term becomes 0 because you know sine of 0 is 0. So you can get this first curly bracket, and here now we have to put u is 2. When you put u is 2, this term becomes 0, and this term minus 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 3 times, so it has minus sine lambda u is 2. So sine minus sine 2 lambda upon lambda square. Then you have to put u is 1. So when you put u is 1, what will happen? 2 minus 1, that is 1. Minus minus became plus. So cos lambda upon lambda. The minus minus minus. 3 times minus. Another minus. So plus sine lambda upon lambda square. You can see few terms get cancelled. Two terms get cancelled. Two terms can be added. And ultimately we can obtain the value of fs lambda, which is nothing but Fourier sine transform of the given function. Now here is example number 8. The question is here, solve the integral equation. Integration from 0 to infinity fx cos lambda x dx equal to 1 minus lambda if lambda is between 0 and 1, and is equal to 0 if lambda is greater than 1. Now you know a differential equation. Equation containing derivatives is called a differential equation. Likewise, equation containing integral is called as integral equation. So remember, to solve this integral equation, that is to obtain the value of small f of x which satisfy this equation. And what is second part? And hence show that integration from 0 to infinity sine square z upon z square dz is pi upon 2. Now just I explained that this is the integral equation, and to solve this integral equation, that is to find the value of f of x. Now see whether this type of expression, this left hand side is present in some of the standard equation. Exactly, it is a present in equation 2a. So from equation 2a, fc lambda is equal to integration from 0 to infinity f of u cos lambda u du. You know, variables does not matter in definite integral. Here u is a variable of integration, and here x is a variable of integration. I want to say that this integral and this integral, they are same. Hence this integral is taken as a fc lambda. So this is your equation 2a. So using equation 2a, we can write this given integral equation as fc lambda is equal to integration from 0 to infinity fu cos lambda u du is equal to this. Okay, so here either you use a x variable or u variable, does not matter, because variables are immaterial in definite integral. Now considering first and last, you can see that fc lambda will be a function having the value 1 minus lambda if lambda is between 0 and 1, and 0 if lambda is greater than 1. Let's call this equation as 1, and that means we know we have obtained the value of fc lambda here, from which we can find inverse. Now inverse Fourier cosine transform of fc lambda is given by this equation. Already we have used 2a equation. See, this is equation 2a. This is nothing but equation 2a. We have used equation 2a. Fine. And now we have to, our target is to obtain the value of f of x. Because here from the equation 1, we know fc lambda. Using this value of fc lambda, we can get the f of x by using equation 2a. And now as you can understand that here d lambda represents lambda as a variable of integration, and so for this integration x is a constant while lambda is a variable. This you have to understand, that for this integral lambda is a variable while x is a constant. Now we put the value of fc lambda, right? So when you put the value of fc lambda, first term, because for the interval 0 to 1, the fc lambda is 1 minus lambda, while when lambda is 1 to infinity, the value is 0. Now second term directly became 0. Remember here, as I said before, that here here this x is a constant, right? Here x is a constant, fine, and here lambda is variable. So here there is a multiplication of product of two function of lambda. One is 1 minus lambda, another is cos lambda x. So this 1 minus lambda is a polynomial in lambda. So take it as a u, and this cos lambda x you can take it as a v, and now apply generalized rule of integration by parts to the first term. Second term is very simple. Second term became 0, and in integration by generalized rule of integration by parts, we have to write the polynomial 1 minus lambda as it is, and we have to integrate this cos lambda x, which is sin lambda x upon x, because x is a constant here. This next term has a minus sign, and derivative of 1 minus lambda with respect to lambda is minus 1. Then integration of the sin lambda x upon x with respect to lambda will be minus cos lambda x upon x into x, that became x square. And here limits for the lambda are lambda is 0 to lambda is 1. Then you simplify this, and when you put lambda is 1 and then minus sign, then put lambda is 0, you can get this kind of the f of x, right? This f of x, this value of f of x represents a solution for the given integral equation. Now this you can see, this is equation 2a. In 2a we have to put the value of f of u, but we don't know f of u, we know f of x, so replace x by u here. The f of u became 2 upon pi into 1 minus cos u upon u square. Fine, you can get this kind of step. In next step, we know formula 1 minus cos theta equal to 2 sin square theta upon 2. Using that formula, you will find this new numerator. Fine, and here now to evaluate certain integral in the problem, we put lambda is 0 on the both side. So in left side we put the lambda is 0, so fc lambda at lambda is 0, while in right hand side when you put lambda is 0, you will find here cos 0, and cos 0 is 1, and further this 2 and this 2, okay, this 2 can be no doubt, and fc lambda at lambda is 0 became 1 from the definition of fc lambda, and further we put u upon 2 as a z. When you put u upon 2 as a z, that means we are converting variable u to z. U became 2z, du became 2 dz, and this integral can be converted to z. And further you can see that after simplifying, the value of the integral 0 to infinity sin square z upon z square dz became pi upon 2, and which is required actually. Now here is 9th example. Solve the integral equation. Same question can also be asked as a find inverse Fourier transform of fc lambda equal e raised to minus lambda comma lambda greater than 0. Same question can also be asked as find f of x if fc lambda is equal to e raised to minus lambda comma lambda greater than 0. Now here simple thing you must know for this problem, that is integration of sin x is a minus cos x plus constant. Okay, so as you know, to solve the given integral equation, that is to find the value of f of x which satisfy it. Already I said you this, and now you know this equation. This is equation 2a. fc lambda is equal to integration from 0 to infinity fu sin cos of lambda u du. Fine. Now you know variables does not matter in definite integral. You can see here this, here variables does not matter. Here x is variable, here y is variable, here u is variable. So here u is variable, you can change the variable. So you can change the variable u by x. When we change a variable u by x, you can have this, and here variable can be changed. I said you just, and you know a equal to b equal to c implies a equal to c. So using this, we can say that fc lambda is e raised to minus lambda greater than 0. Remember, we have to obtain the value of f of x, and to find the value of f of x, when fc lambda is known, you have to use equation 2b. So this is equation 2b, and where you have to put the value of fc lambda. So we'll put the value of fc lambda, it is a minus lambda, and for this integration x is a constant while lambda is a variable. So we have to make use of this standard formula. So let's use this standard formula. So when you use this formula, you will get this kind of integration, and e raised to minus infinity is 0. So we can get the value of f of x, and this value of f of x represent solution for the given integral equation. These are the two references we have used. One book from the B.S. Gravel and book from the S.R. Sakti sir, B.S. Wage sir, myself and Naveen. Thank you very much for watching this video completely.